Hello, everyone. We're going to start. My name is Luis Meijueiro. Let me introduce where I work. This is one of the partners of the project, CTIC Centro Tecnológico in Spain. We are a non-profit private foundation. We have 70 people, and we work in all those technologies that you can see: web standards, blockchain, obviously, artificial intelligence, augmented reality. We started a blockchain lab around 2015, beginning with the research on this type of technologies, blockchain and what is called DLT, that is decentralized ledger technologies, mainly to see what we can do with these technologies, if they can fulfill what they promise and things like that, before they became a popular trend in the recent years. Then we started with most advanced types of this technology that we call the blockchain 2.0 around 2016 and mainly 18, era of blockchain technologies that we can call 3.0. That is really when we can get all the main benefits that can deliver to the general public, not only to some innovative businesses. And that's currently the type of technology that we are going to apply in this project PLASTICE. Well, let's start with a brief overview of the main technologies involved in what is called blockchain, mainly for all of those of you that you do not know many about it. Well, where everything began with this blockchain network that you have heard of, that is called Bitcoin. Bitcoin is not only a currency, a digital currency or cryptocurrency, it's also the name of the system, of the IT system, the network that makes possible that transfer of value, financial value, between peers, between individuals, without the middleman, without any type of organization like financial institutions that usually drive our usual or regular financial system. And it was the paper, the famous paper, but an anonymous person, this is an alias, we think, Satoshi Nakamoto, that wrote this paper, not only explaining in literature what was this network about, but also the technologies involved and also the mathematical formulas and methods behind that supported the validity of this type of system for financial transfers, like the paper said, peer-to-peer electronic cash systems. The main problems and why this was really disruptive is that changed the type of making business in this financial system, made possible the transition from a centralized system where we needed trusted partners to make those financial transfers, banks mainly, versus a new system that is distributed, is decentralized. With Bitcoin, you do not need a bank. You can transfer value, transfer Bitcoins, that is the cryptocurrency, directly between individuals, between businesses, but without any other type of middle institution in the transaction. And mainly, this network, what made possible was preventing the double spend. Double spend is that in the digital world, you know that you can copy anything. In the digital world, there is no original and copy. Imagine a PDF. You create a PDF from a document. It's perfectly identical. So the problem is that if you have a digital currency, you can copy it in some sort of way, and you can produce Bitcoins from nothing. That's not possible because there are some tricky features in the network, in the system, in the code, based in cryptography and other types of technologies that prevent that anyone can produce their own Bitcoins and double spend it. Let's go deeper in these technologies that support this type of system. But first, we will talk about the previous context, as I said. More or less the last 4,000 years, we have been working in a centralized way with this type of centralized business logic. There is an anthropologist, an British anthropologist, maybe some of you have heard about this number, Roger Dunbar number, that says that we as humans could not have more than about 150 meaningful relationships. Obviously, you can have many more friends in Facebook, for instance, but really you only can tell more or less your brain can speak about this type of 150 relationships. You know more or less then if you can trust or not in them, and so on. That's more or less because of our brain was shaped in this type of communities long ago. That's the explanation of these anthropologists. And we, mainly our history as humans, we have lived in little communities as a tribe or something like that. Then our cities began to be bigger and things like that, and to establish commercial relationships between other parties that are not in that circle of people that you know, that you can trust on. You have to do it using a trusted party, a trusted partner. That's the way that we overcome that barrier, that human barrier or brain barrier, and can enable broader businesses relationships. That's the way the commerce can flow and you can make commercial transactions between different communities, between countries around the globe, using these trusted partners. But remember what happened in the recent trust crisis with Lehman Brothers and so on, and more or less is the years where Bitcoin passed. These trusted partners globally was admitted that were not so trusty. You cannot trust so well with these intermediaries. Bitcoin and other blockchain networks appear. That way you do not need these trusted partners. You can make transactions, commercial transactions, financial transactions in the case of Bitcoin, directly between individuals or between organizations. But you do not need these old trusted partners using this type of networks. If we talk about the technology context that the most advanced technology context that we're using these trusted partners and ourselves to create these transactions was the cloud computing. Is this type of hype word that we have been using recently. You do not usually have a mail server on your own organization. You trust a partner, like imagine Google with Gmail or other type of service provider, and you use cloud computer to deliver your emails, for instance, or any other type of financial transactions. They are based in cloud computing, in big data centers where the software and also the data is stored, is updated, and that's the type of IT systems that manage your information and your transactions. That was a trusted model because you need a trusted party that you rely on them to manage that IT systems and data, versus the trustless model. The trustless model is this distributed computing. Every partner, every node of the network, of these blockchain networks, is responsible of running the whole IT systems, their own part of the IT systems. They collaborate with their own machines to run the software and also to store the data. And that's the trustless model. Why trustless? Because in this model, you do not trust anyone. They have to prove their validity to do transactions one by one. let's go ahead. What are the technologies at play in blockchain? I am not going to go too deep in any of them, but just show you what are them. The blockchain technologies and Bitcoin, it was not an invention, it was just a mix of technologies that existed, but they were witty connected, witty merged to create this, what is called blockchains. We had peer-to-peer networks. That was something that was viable before Bitcoin and blockchain. For instance, these networks to share files between individuals directly, we had also the time stamping. Time stamping is usually, you can see it in the logs of the servers. The servers had many logs, or even your computer had logs about what is happening or issues that are websites, for instance. The web servers have many different logs about users connecting, disconnecting, and things like that. And a log is just a registry with the timestamp, the time with minutes and seconds where something has happened that is remarkable for the system. Another technology is cryptographic technology that is used heavily in these blockchain networks. One very common thing is the hash function. The hash function is a function where you feed it with a type of a data of an arbitrary size, and it resolves with this hash function and gives you a fixed size value. In this case, usually it's an hexadecimal value. In that, you can see only an example where you feed Maria with different sign in the eye, or a full name Maria del Carmen. It doesn't matter if the characters change or if the length of the character at the feed of the function is different, that you get a fixed length hexadecimal value. With that hexadecimal value and the hash function, you can get the original data. That's the way these hash functions work. You will see later why this is used. And another technology that is used in blockchain is the public key cryptography. Digital signatures that you may happen to use to sign documents digitally, PDFs for instance, or another type of documents rely on this type of cryptography. It is just a private key, which should not be known by anyone, just by you, the owner of the key. And there is a public key. It's like your address. It's the public key that you share with anyone that can verify that you have, for instance, signed a document. That is also used in blockchain networks. Well, and then using all those technologies, we came to the term blockchain, and I will explain what is called block and chain. It's a chain of blocks, like the word says, with transaction data. The data that is stored on this type of networks is not a database. It's not like a database. It's more like a ledger, because really the information is stored in files, in chunks of files that are concatenated between them. And logically, they are concatenated in a block. A block is a unit of information that has many transactions, several transactions, and the block is of fixed length of data, but you know that every transaction can have different length. So that's why one block can have, imagine 3 transactions, but another block can have 10 transactions, because this transaction has different size, and when the block reaches the full size per block, the chain creates another block to store the new transactions that is coming. The thing why it's called a chain is because this blockchain system applies to everything that is being stored these cryptographic functions, these hashes, and makes a hash of every transaction. And when the block is full, also makes a hash of the block. And then when a new block is created, the new block stores the hash of the previous block. So this is a chain made of blocks. And why is that used? That use is because if you alter something of the data, the hash is different. The hash function, as you said, as I showed in some previous slide, creates different hash for different input data. If you alter the data, the hash will vary. So that's a way of detecting if something has been tampered, something has changed. And the chain can detect it because everything in the point where it's changed, everything that is coming after that will have different hashes. So you will know where is something has been changed. That is one thing. And another thing is that every transaction that is stored has a timestamp. And there cannot be two transactions with the same timestamp. This time sequence is guaranteed because every transaction has an order. So that's a way of guaranteeing also that you cannot do double spend, duplicate transactions, or things like that. And I've talked about the peer-to-peer networks. So there are nodes that are connected, and these blocks and this data is stored in every node. It's not that one node, that's the centralized model, one node has all the information and all the rest of the nodes rely on that. No. In blockchain, every node of the network has a copy of the chain of this transaction. And why do they that? Because it's trustless. No one trusts the other node. So every node has to make its own calculations to check if something has changed that should not have changed, because the hashes are the same, identical, the time sequence, and that. And that type of management of this information that is transparent for the end user, obviously is in the system, is what we call the consensus algorithm. Is those machines get a consensus about what is the good change, the change that everyone can rely on, and in the end, the data that they can rely on. But as you know, this type of transactions are made at the speed of light, obviously. In the meantime, there are different versions of chains growing, because this is not synchronized, it's a asynchronous network. And there are delays because nodes are in one country around the globe, so there are delays. And then nodes can have in a moment a partial view of the chain. These consensus algorithms makes that, gets a consensus between all the nodes about what is the good chain, and they can rely. And this is happening in real time, every time. You can see it's a complex system technologically to guarantee that you can rely on the information, and that's why it's very secure, because it's more or less this type of storing information is tamper-proof. You cannot alter it, you cannot delete, you cannot update, you only store in a way that you can be confident on what is the information stored. Well, let me now talk about blockchain platforms. We have talked about the technology, the basis of the technology, but what are currently, let's say, the commercial products? What are the platforms that you can use to use a blockchain network, to store information in that innovative way? Well, we have talked about Bitcoin, obviously, was the first one that used this technology to store just one type of information, that was financial information about value, about a digital currency that is called Bitcoin. That was the first generation of blockchain platforms. There were other platforms that were more or less clones of Bitcoin. And why clones? Because one important thing about this type of technologies, obviously, is a software, is a code that is run by computers, but it's open source code. That's important. So anyone can get that code and copy it, make a fork, what is called, alter something, change the consensus algorithm, change some parameters, and make their own new blockchain platform. That's why there are many others based on Bitcoin, like Namecoin, Ripple, Litecoin, Stellar. But the second gen blockchain platforms appear with Ethereum. Ethereum is a platform widely known, probably the most advanced, not advanced, but used currently, the most popular, and appear using many of the technologies of Bitcoin, but added a new feature that was that these nodes not only can run a code that is used to manage financial transactions. Now with Ethereum, they added what they called smart contracts. I do not like the word because they are not smart, not contracts, are just code that is running every node. But with this type of code, you can do different things, not only financial transactions. You can use it to code more complex functions to manage any other type of information. The aim of Ethereum is like make a global computer. To like you have a computer on your own to run these types of nodes that can run any type of solutions for any kind of industries. So that's why it's very important. They exploded this smart contract technology. And obviously the same is open source, so many other people or communities get what they were interested in the Ethereum system and made their own chains. Open Chain, Hyperledger, Corda, Quorum, that is also more or less like a clone of Ethereum but for private networks, and so on. And we are now currently in the third generation platforms. We can talk about EOS.io. Telos is just a flavor of EOS. We have also Eternity, Tezos, Corda, many other type of chains that added a new consensus algorithm that was more focused on sustainability, to consume less energy, for instance, and also they focused on governance of the network, adding some features to allow the general public more control over the network. Obviously, this third generation used the same functions like a smart contract that were in Ethereum. That's the type of blockchain platforms. There are many other names, but I just show it like an example. Well, I will pass this slide. It's just to show the things that I talked about in Ethereum. That is the most popular one, the global computer. There are more or less 8,000 active nodes in every moment. There are more nodes, but active that currently around the globe. It was crowdfunded. It used proof of work, that is the name of the consensus algorithm, that is very energy consuming. But this year, a transition to another type of consensus algorithm that is called proof of stake, that is more energy friendly. This type of platforms use their own currency, in this case is Ether, and has user accounts. And we will just stop here to show you that what I've called smart contracts are just programs, computer programs that are executed in every network node, not just in one node, in every one. Because remember, it's trustless. Every node has to execute everything and check if the result is the same in every node. What the end user uses, the interfaces, applications. We call it decentralized applications because usually they are run in every node in a decentralized way, not just in a web server or things like that. And they have a user node interface like HTML, JavaScript, like any other web applications. And there are also tokens. Tokens are currencies that you can create. A part of the native token, that is the cryptocurrency of every blockchain network, Bitcoin, Ether, you can create your own token. Imagine that you have tokens that you can use in the fidelization programs with your clients, for instance, or so on. You can create tokens, own tokens in that. It's just a contract, a code that you can use with what is called wallets. Let's go ahead. Well, the main thing about all of these blockchain technologies is the idea of the decentralization. And here you have to know two types of decentralization. There is one that is the infrastructure, that is the number of computers, and the percentage of them that are fault tolerant. That's it. How many computers can you sacrifice and your system, your client system, IT system, deliver what the services, the products that you offer. That's the grade of decentralizations that you have in your infrastructure. Obviously, you have only one server. If your server is down because it's attacked by a virus or something like that, your decentralization is very low. If you replicate your web server in another data center, okay, that's more decentralized. And if you have 20 web servers, you are more or less very decentralized. But there is also the governance of your infrastructure. That is the other type of decentralization. How many individuals or organizations have control over the infrastructure? You can have 20 computers replicated around the globe. You are very decentralized in talking about your infrastructure, but you govern all of them. You control all of them. So you are not decentralized in the sense of governance. Well, in the traditional or the trusted world that we have talked about, where you use trusted partners, there was no decentralization at all, not in infrastructure, not in governance. But blockchains is decentralized in both, in infrastructure and in governance, because of the trust-led model. What does it mean for the businesses? Well, you can see in this type of graph, traditional model of business, decentralized, where you usually have, imagine, many of industries use this model. You have a producer, a manufacturer, a consumer, and in the middle you have suppliers, carriers, authorities, distributors, logistics. But as you can see, more or less everything goes through the manufacturer. And in many cases, the manufacturer is what has the power, the control, the governance about the data flows in this business network, because it gets information from the producer, from the supplier, and delivers information to the consumer, to the distributor. So it's more or less the middleman. Maybe, depending on the industries, this type of logic varies, but more or less is what you can encounter. And what gives you blockchain? Blockchains goes in the middle. The infrastructure is the middleman, the own infrastructure, where every player, every actor interacts with, and obviously can interact directly with any other player. Talking about PLASTICE, I can put more or less all of you in this schema. For instance, imagine demo site 1. In demo site 1, we have Cogersa and Urbaser as producers. There are other players that are in the manufacturing side, the demo sites per se, and in the other part there are the consumers like Total or other ones, and we can have authorities, in this case for demo site, the Spanish authority mainly, and maybe suppliers of any components or any things we need, distributors to deliver the end product, things like that. In blockchain, that's the model, the technological model, I will explain it later, that we are going to create. That demo site, we will connect with an API or with a human interface, these web applications, and interact with the blockchain registry to store and retrieve and query the data in that way that I explained before, with that technologies that are tamper-proof, you can trust them, and so on. And for the rest of the demo sites will be the same, just changing the players, as you can see here in these slides. Well, we have to decide what are the platform implementation. We have talked that we are going to implement to store that type of information that all of you will provide to this tool, to this IT system, and we have to decide between those implementations, those platforms, Ethereum or EOS.io or Corda or Hyperledger, what type of blockchain? Well, these networks usually choose between these network configurations. Let's call between blockchain or DLT, distributed ledger networks. Because blockchain is what you can see in the green column. This is what they are. The type of access is public. Decentralization, as I said, is total, are governed by anyone. Anyone can register, can send transactions, query transactions, and is anonymous. That's a good characteristic in the public blockchains. But some businesses or some companies do not like the anonymity, for instance, or do not like that everyone can govern the network. They do not like the decentralization of the governance. They like the decentralization of an infrastructure because their costs are lower, but do not like the other one. So they make, for instance, a consortium network. That is a club. It's a club of companies that rely on this technology, but do not use some type of algorithms that provide that open network to the public and things like that. And obviously there are private networks. I don't know why. It's a private network because if you want a private network, you can use a database, regular database, and you will get more speed, more reliable, but someone create private networks. And I more or less mapped the name of the platforms at the end, some examples where you can see. Pure blockchain is Bitcoin, Ethereum, EOS, Telos. Distributed ledgers in consortium models is Quorum, Hyperledger Fabric, for instance, and private are Nomax, Multichain, some of these. And like English people say, the devil is in the detail. For me, or at least in our opinion, CTIC, Centro Tecnológico, we push for public networks, for the blockchain in reality, because we think that disruptive innovation comes with blockchain, not with DLTs. But it's something that we can discuss at the end of this workshop. Because we need for disruptive innovation, enabling technology, blockchain, an innovative business model, decentralized, and obviously a coherent value network. And this coherent value network is the network, is the nodes. Are you and your business are the value network. So we have to decide if we go with a public blockchain, pure public blockchain, or we have a consortium one. I myself will discard private one, obviously. So that's the type of questions that we have to decide. This what I call the digital transformation dilemma. How come an enterprise makes compatible their customer-centric strategy with a private blockchain? It seems incompatible. You talk about your customer, you work for your customer, you design for the customer, and customer-centric design and things like that, but you then use a private blockchain, so the customer has nothing to see, nothing to access to. You have to always give them permission to see things. Then why do you use a blockchain, for instance? Or some people say that okay, shared ledgers or this consortium can do what the public blockchain can do. Well, let me doubt it in some cases. And some people say that market solutions cannot succeed on public blockchains because they do not want to share information with other people or commercial secrets or something like that. They see this type of things. Our organization has many years working in IT, and we have seen what happened with internet. The value of internet exploded because it was open. Everyone can access internet, not intranets. You know what I mean? Intranets are good use for a club, but the businesses are global. So if they are global, they have to use an infrastructure that is global, like is internet. So public blockchains are global, are public, and consortiums and private blockchains are closed just for a group of people. So we have to decide if our future business is a private club, will just deal with a private club, or is aimed to go with a broader audience of companies and things like that of our products. So this is important for you to know that blockchain, not by using blockchain technologies, you will inherit all the benefits of those technologies. Tamper-proof, very secure, cryptography. You will not inherit it if you used blockchain applied in a centralized model, not goodly applied. You have to understand that blockchain is not primarily meant to solve technical or business problems, nor interoperability nor traceability. Blockchain is all about decentralizing markets. And now you will see this more clearly with some examples. Let's talk about blockchain-based solutions. That is what we are going to develop for PLASTICE. What is a definition of blockchain? For me, blockchain is an advanced, because of that combination of technologies, IT system. It's a combination of hardware, the nodes, the computers, the servers, with the software, the smart contracts, the front end, the end user programs, for sharing valuable information, relevant information for your business in a special way that is in immutable and decentralized ways. There is no single computer, just only one computer that stores the information. There will be many computers storing the information, decentralized, and this information will not be updatable. It's immutable. You only store. It's like a history record. And between actors, not trusting each other. I'm not saying that you do not trust, because we are a consortium. We have also signed very contracts and things like that, NDAs even. We trust each other, obviously. But imagine that the model that we are going to create is to be able to incorporate new partners where we do not know anything about them. So we do not trust them, but we are going to develop a system that is able to work with that partners, not only with us. That's why we say that we do not trust each other. And be very careful. Blockchain is not a kind of super secure database. It's not a database. Blockchain is not efficient for storing gigas of information. No, it's not for that. It's just for coordinating and storing relevant information that must be shared. And the characteristic of that information is that every partner should rely on that information, and that information is the general truth for the network. Practical applications. Blockchain is very good, fits very well where there are global challenges, like PLASTICE. This is what I will be trying to do, tackle a global challenge like is the recycling sector, using all this waste and generating new streams of plastics to be reused. And blockchains, as I said, are very well for coordinating between all of us, all stakeholders. And blockchains, I repeat it again and again, means decentralizations. All of you have to participate with this technology, coordinate your activities, and share these norms. Norms are the business logic that we have to define and implement in the code of the network, and all those nodes that you will run, us will run, will rely on. And everyone will see the transactions that are flowing between the network, and that's what is the accountability. It's a joint responsibility. You cannot rely on someone to send your transactions. No, you have to send them by yourself, sign with your own key, with your own private key, to store it, not rely on another, because if everyone relies on a party, you know what I mean, you go towards the centralized model, and we do not want the centralized model. It's decentralization. Blockchain is not meant to be implemented by a single enterprise or two enterprises. It's for a network. Remember, decentralizing markets. So a market is comprised for all the actors, and has been applied in many use cases for public administration, for education, logistics, energy and utilities. Currently is trying to be delivered in many industries. Some practical examples. For instance, for the vehicle industry, we developed an application, a use case that we call card trust chain, for instance, that try to prevent the consumer fraud, also improve road safety and air quality. When you buy a second-hand vehicle, a car, for instance, you cannot rely on the mileage that car has, because it's easily tampered, even though now these cars are governed by digital technologies, is more easily tampered. So to prevent this automated fraud, one solution is to register from the very beginning of the life of this car in this type of tamper-proof storage solution that is a registry on the blockchain, using a public blockchain platform. Why a public blockchain? Because everyone can check and see these transactions when the vehicle went through some revision, some maintenance, and so on. And then when you sell that car to a potential buyer, this buyer can check and see more or less the history of the vehicle, compare it with another type of vehicles of similar characteristics for the same country, between countries, and then can detect some strange things that fits not very well with the medium, regular, standard usage of a car of that characteristic. Another thing is, for instance, for elevators, for machines. Machines now are with the IoT, with the Internet of Things, are connected to the internet. They can send many alerts of what is happening to them, what are the issues, security, breakdown, services, and warranty. And there are many actors or players interacting with that machine. The owner of the machine, the enterprise that gives a warranty service, the repair service, and everything has a copy that currently they do not share of their own data. They can share it through a blockchain that is tamper-proof, and they have a history of that machine. And finally, the traceability world is also relying now heavily on this type of technologies, because also you can get supply chain integrity and protection of your goods from, for instance, counterfeit or overproduction. This example is for a beverage that is cider, that is very popular in our area, but you can use it, apply to any agri-food product, and we use it to register, obviously, and querying the information for these processes using a blockchain platform. And finally, we are in the end part of this workshop. The traceability tool for PLASTICE project will be based more or less in these traceability applications that we have tested and developed. This slide, you have seen it in the original kickoff meeting. It is more or less a representation of the connection between systems, between the demo sites can connect with an IPA, that's in a system, a programmable interface, where your systems can connect and talk the same language, sending the values, the parameters to the API that will store automatically this information on the blockchain via this code, smart contracts, and so on. There will be also another way to do these things without if you cannot connect your systems. You will have a user application, a web application, where you can interact and send manually the information. And this end user application, web application, will be used also by the consumers to query the information that all of us will have stored previously from our processes from the demo sites. What is used, for what is used this traceability? To trace it back, mainly, because the information that the consumer wants is go to the origin, and what are the information and the processes that the product that is buying or is using to create new products have suffered. The viability, the origin, the accuracy of information, the feedback from all the partners. Also used for legal compliance. You know that in some cases there are certain authorities that need some type of documents or information that is an evidence or a proof that you have complied with some regulation. And also you can use traceability for creating loyalty schemes, because issuing tokens can give you a type of cards that are given in a supermarket. You earn points and you can redeem them by discounts or something. You can use digital tokens to replicate that type of business logic. Our usual approach to design this type of tools is this one. We have to choose a convenient part of the whole process. Why? Because as I said, we use traceability that is back traceability, not everything, not the traceability that you may need for your own processes to create some middle product and things like that, because the way you do that, sometimes the end consumer does not care about that. Maybe it only cares about what type of materials are you using, or what type of processes, for instance, that you do not employ child workforce or something like that, but not if you have used this machine or this type of machine or other. And obviously the second part is select the attributes, that's what I'm talking about, of the good to be traced. Attributes that are of interest to the end consumer. We then create a simple and functional first pilot, and we test them with all of you, with all the parties, and foster collaborations to improve it, to fine-tuning it. So what we want from you, like Uncle Sam says, is one, we need your help to choose this convenient part of the whole project. So we have to identify, with your help, for each site, what are the specific processes that source the relevant information that must be shared along the chain. Then we also need your help. We know the processes. Now we have to select the attributes of the good to be traced. And that is identified for each product, for each stream, the relevant information that is useful for the final consumer of the product. For total, for all the partners that are in the end part of the stream, that they know what they need to know about the product, the quality, the parameters that they need. In the example of the cider, the left part of the information are the processes, for instance, the farming, the corking, the pressing, and in the right side you can see all the information that the consumer wants. The consumer wants to know what type of apples you are using, the origin of the apples, and things like that, the information about the cidery, that are the relevant information that we have to select. You have to think about it and tell us that about every demo site, and that's what we need for you. And that's my final slide. Thank you for your patience hearing all this information. I know that is much information, but as we said, this workshop is being recorded, and we also will share the PDF of this presentation. Now we can get a brief round of questions.